My name is Cristian Hesselman. I'm with SIDN Labs. We're the research team of SIDN. And as you may know, SIDN is the registry of the .nl domain. So we host and publish all the 6.2 million .nl domains on the internet. And this talk will, I think, will be a little bit different than will be somewhat different from the talks we've heard before, because this is going to be about the internet infrastructure. That's why I highlighted the word infrastructure in the title, because it wasn't in the original title that you found in your booklet, I think. So I added infrastructure. So that's what this talk will be about. And it's also a new concept that we came up with in the TwoStick consortium. TwoStick is an acronym for Security, Stability, and Transparency of Inter-Domain Networks. So it focuses on the internet infrastructure and trying to make that more secure, transparent, and stable. Okay, so this is a collaboration with a bunch of universities, the Amsterdam Internet Exchange, the Dutch Netherlands Internet Exchange, and SURF. All right, so next. All right, so just to start off on with a little introduction on what the internet is. Does the term autonomous system ring any bells for folk in the audience? No, not really. No. Autonomous system is similar to, it's like a unit of ownership on the internet, and it's a network that's being administered by a certain administrative organization, you know, like your carrier, for example, like Ziggo, or a cloud service like a hosting provider like LeaseWeb, for example. And the internet is basically a collection of autonomous systems. So what you're seeing in the picture on the right is that if you visit the website www.idnext.eu, you don't get there, let's say, through one single hop, but you get there through multiple autonomous systems, so through multiple networks. Okay? So in the example, the traffic, the web page that you receive from the IDnext server goes through autonomous system 8, then through autonomous system 6, 2, 1, etc., and then it ends up at your mobile phone. Okay? So, and if you do a trace route on your laptop, so that's a command to kind of get this type of information, you will discover, at least when I do that at home, that your traffic goes through Vodafone Libertel, Ziggo, there's GTT, and there's LeaseWeb. So there's all kinds of different organizations between you and the server from which you obtain your information. All right, so the internet, you see Google, you see your IoT. From an end user perspective, it's a black box. You throw in data, or you throw in a request and you get the data, right? And everything else happens under the hood. And that's all what I'll be speaking to in a few minutes in a bit more detail, because we have a proposal to, so we're going to outline the problem with that and a proposal to improve it. So the internet, so these autonomous systems that you saw on the previous slide, there's actually quite a few of them, so over 70,000 at this point. So as you can see, the internet is a huge beast, so to speak, that is interconnected through these 70,000 different kinds of networks and organizations. And as you can see, it started back in 1996 or something, at least these measurements started back in 1996, with a few hundred of these autonomous systems, okay? So that basically shows how much it has grown over the past couple of decades. But we think there is also a problem. So the internet has been a huge success, but at the same time we're seeing this tension between being increasingly dependent on the internet infrastructure. So this is, of course, the whole digital autonomy discussion. So being and services and storage platforms, but we have very limited insight and control who operates these systems, how they work, and who manages them. So there are two concerns here. One is the discussion about the integrity of the infrastructure. So this basically is about the discussions we've seen in the press, for example, about Huawei routers potentially not being trustworthy, or the NSA installing rogue software on router systems, that sort of thing. And that may have a potentially huge impact, because if your back-end systems, if your infrastructure systems are insecure, it can disrupt your entire society, right? It could result in theft of data, or devices being disconnected or corrupted, or that sort of thing. So with a digital society that increasingly depends on these digital systems, that is a risk from a societal perspective. Okay, so think about these new types of applications, such as autonomous driving, smart energy grids. So basically, the type of applications that interact with physical space, that interact with humans, you could say. And the second concern in this digital autonomy discussion is about the dominance of a few large players, such as Google, Facebook, AWS, those kinds of often United States players from the United States, because they get all the that's where the power concentrates, both in terms of who has access to the data, who runs the systems, and who has the knowledge. And this is a risk for society because it is something that is kind of could potentially stand in the way of the direction that societies want to take. Okay? So they basically kind of risk losing control over their own direction. In addition, it's also an operational risk, as we saw a few times already. So we saw the outages of several websites a few weeks ago, which was because of operators like Cloudflare and what's the other one, Fastly, on which a large number of sites depended, but had it, got disrupted, and then all these sites that depended on them got disrupted as well. Okay, so increasing dependency, but no insight and control over these systems, and two concerns there. So the integrity and the concentration or dominance of a few large players. That together, we think, reduces trust particularly relevant at the network level. So basically, have they been security audited? Okay, and this is, we think, is particularly a problem for applications that not necessarily for web browsing or sending emails, but for applications such as these smart energy grids or autonomous systems, autonomous vehicle systems, or maybe even ships that get steered to a harbor autonomously. We just saw the presentation by that gentleman over there on the Rotterdam port, so that might be related to. Okay, so no insight and control, and particularly this is an impact for the safety critical applications. And we're not the only ones seeing that problem, because there are similar concerns in the space of artificial intelligence. So there is a development called artificial AI, where there's concerns on how these AI algorithms reach a certain decision. So there's demands for more transparency how these algorithms come to certain decisions, because they can affect people's lives, right? They can, sometimes you may not get a mortgage, for example, because people then want to know why. And the same goes for cloud services, because we have this new development in Europe called Gaia-X, where we're trying to set up the European cloud service that's more transparent and where folk have more control of the data that they put in that cloud. Okay? So the data autonomy problem is does not only pertain to data in transit, so when it flows through the network, you could say, but also pertains to when it's being used and when it's being stored at a cloud service. Okay? So with this problem in mind, we think that it's time for a new communications paradigm for the internet. So I'm still talking about the network level communications platform now. So what we think needs to happen is that the internet infrastructure gets more transparent, more accountable, and more controllable. So we call this the CAT principles. And we think that these, I'll be talking about that in more detail later on. But we think that these three principles basically are in the new stage, or a new stage in the development of the internet infrastructure. So back in the 60s, 70s, 80s, we had the first stage where the internet was deployed and was trying to reach ubiquitous deployment. That was the main goal there, trying to get it to perform, for example. Then since roughly the 2000s to 2020s, we realized, well, security wasn't really part of the original design, nor was privacy, so perhaps we need to do something about that. And then there was a lot of discussion about protocols that needed to be added, security extensions for the routing system, the domain name system, certificates, that sort of thing. So that was basically stage 2, at least, that's how we see it. And then we think that stage 3 would really make the internet infrastructure more transparent, accountable, and controllable. And we think that this is necessary to make the transition from the original structure of the internet, which is at the top, the bottom left over there, where you have the internet consisting of only a few nodes back in the 1960s, all the way up to the new types of applications that we foresee for the 2020s and 2030s. Again, these smart energy grids and autonomous vehicle systems, for example. Okay? And we also think that while we need to make that transition, a few of the key properties of the internet infrastructure we need to keep. So it needs to stay open, it needs to be a general purpose platform, and it still needs to stick to this decentralized ownership and control, so the autonomous systems construct, you could say. So how do we aim to accomplish this? Through a concept that we call the responsible internet. So this is something that's still on the drawing board, and we have a bunch of projects running at this point that we, with the universities that I just spoke about, that try to, with whom we're trying to flesh out this concept, you could say. So what it's trying to do is addressing that lack of insight and control over the network infrastructure by adding these CAT principles. So controllability, accountability, and insight. So this is what you're seeing on the right over here. Does it work? No, not really. Anyways. So what you're seeing in the graph is this is the internet infrastructure as we know it today, with the Ds representing the autonomous systems, because they're sometimes also called domains. And there's what we're trying to propose to make the infrastructure more transparent is to do measurements of the internet infrastructure. So we basically create a map of what it looks like. What are the autonomous systems? What are their properties? What are their security levels? What are their jurisdictions? All that sort of thing. So we can do that through measurements for a large part. And then we also envision that these autonomous systems publish some of that information themselves. Okay? So it's remote measurements and then also self-measurement, you could say. And that's something you can combine in an internet map, so to speak. That will be what we call a network description. And based on that network description, relying parties, such as the service providers or individuals, they get more insight into what the internet infrastructure looks like under the hood. And that gives them more insight into the security properties of these networks, for example. So this means that they can potentially influence which autonomous systems they want to entrust with handling or forwarding their data. Okay? So that gives you more insight. And then the second part that we need is controllability. So we need a network that also enables these relying parties to express what types of autonomous systems or what types of networks they want to use for forwarding their data to the remote destination. Okay? So this is where the cycle goes like this, creating a map of the internet infrastructure, getting that insight, and then using the map to be more in control of how your data flows flow through the network. Okay? So that's the main concept, and we think that having that information at the top and having that controllability gives relying parties more confidence and trust in using the internet infrastructure, which we think is important for these new types of applications. So here's a few examples on the added value that we foresee for different types of players. So for example, for these critical service providers, let's take a smart energy grid as an example. They can have more control over which autonomous systems they want to use for forwarding their traffic. So rather than running their own network, they can simply use the shared responsible internet to transmit their data, because they know to what level they can entrust the various networks through which their data flows. Okay? We also think it has an advantage for policy bodies, maybe national governments, for example, because they have more insight through these network maps, so to speak, on how the network infrastructure evolves. So if there's single points of failures, or if there's concentrations of power in a certain region or in a certain country, then policymakers could potentially spot those those points more quickly with a responsible internet. And also for network operators themselves, we think that sharing that information that we just talked about, so we had the picture with we had the self-measurements. If you share that information with other network operators, it also becomes more, you can address large-scale incidents more quickly. So a couple of years ago, we had a large outage where a DDoS attack took out a large number of, a DDoS attack through a botnet took out a large part of the internet. And if the various organizations would be able to share their measurements of that event with each other, they would be able to handle it much more efficiently and much more quickly. And finally, we think that it's also interesting for users to have that insight, because they can control how their personal data flows through the network. Right, so just to give you a little bit of a flavor of how we think this can be done. Of course, this is a huge endeavor. It's not something we can do on the back of an envelope in a week or something. But for these various building blocks that we discussed, the controllability, the accountability, and the transparency, there's existing technologies that can be reused, right? So for example, for the transparency, we can do active measurements of the network infrastructure, or we can rely on self-descriptions, and we can use a language like the network description language, or NDL, to describe that whole lot, okay? And in addition to the technology, which are basically the first three rows, we also need incentives for network operators to deploy this concept, and we might also need some policy making, for instance, to standardize different types of, different CAT levels, so different levels of controllability, accountability, and transparency. Okay. So how are we proposing to tackle this problem? Well, through various research projects. We currently established 3 research projects which are being funded by NWO, so that's the Dutch Science Council. And it has a total budget of around 2.5 million euros to work on this concept, okay? And about 10 Ph.D. students, and they are being supported by 20 members of staff from these different universities that I showed before. Plus in this top project, the Catherine project, we also have folk from industry participating in the proposal. Okay, so it's hands-on work, hands-on research based on test beds, joint experiments, and vertical use cases, so to speak. So that's why I was interested in the talk that we saw previously on the harbor application. So it's a hands-on work, so not just papers or not just presentations. And we actually already have 2 ways of doing that. One is the testbed that we set up within the TwoStick consortium. That's a testbed of programmable network nodes, which you see on the right over there. It interconnects various universities, and it's being run on top of SURF's optical network. So that's something that we can use to deploy and to test this concept. And we have a new network technology called Scion, which partly gives this controllability and transparency already. And they also have a testbed, which is called Scion Lab, and that's something that we connect to at SIDN, for example. Okay, so we also have the testbeds that we can use to really implement and validate our ideas. And there's more, but I only show 2 here. So in summary, I think the concept of a responsible internet is a huge undertaking. I think you may have guessed that already. But I think it's also urgently needed if we want to really support the internet applications of the future. Okay? It's our, let's say, vehicle to introduce these CAT properties, so controllability, accountability, and transparency. And we think it also aligns with similar developments elsewhere. So it's not a purely technical effort. It's very much multidisciplinary. We also need to interact with these verticals that I spoke about. So it's not something that technical folk can do in isolation. And I'd be very interested to talk to people here in the audience if they what they think of it, and perhaps to collaborate. Yeah. So there's additional reading if you're interested. It's in the slide deck, so you can have a look later on.
You just turned it.
All right.
We have perfect. Thank you, Cristian. Thank you. Any questions?
So how would you prevent large players that run their own networks and even lay their own sea cables, or large governments who don't really care about the responsible internet but actually like to keep it unresponsible so that they can control it? How would you engage with them in this context? How would you force them to work with you?
Well, you cannot force folk, but I think that so the purpose of one of these projects that I showed, the Catherine project, is to start like the original internet. So start small with a small testbed, and then grow from there on. So what you need is incentives to pick up the technology. So you need to understand, for example, you need to understand what are the operational costs and investment costs of different network operators, and what could they potentially get out of it in terms of new business models. Maybe new services that can be built on top of these CAT-enabled networks, for example. And if you have something like that, then it could go very similar to the internet, and it could be an organic system that grows organically. So that's the philosophy that we're trying to pursue at this point.
To me, it actually sounds like you need to be able to put trust marks on domains, so that you can actually say, I only want my traffic to be routed through entities that have a certain trust mark,
Yes.
which is super challenging because it immediately becomes political, of course. But
Of course, yeah.
But on the other hand, in this room, there's a boatload of people who know very well how to do that, because a lot of us in trust and identity trust mark the quality of person data and people data, which is...
Well, I don't know the concept of a trust mark exactly, but I think I know what you're trying to say. I think that what we need are these standardized CAT levels, so to speak. So levels of maybe a reputation score or whatever you want to call it. And that's the information you need to somehow include into your routing system. So currently, the routing system of the internet says, okay, if you want to go from A to B, then we'll take the shortest path. And shortest path means least number of hops from the source to the destination. But that might not give you the most secure connection, because we know that some routers in the infrastructure have security vulnerabilities, for example. Not because they were infected with malware from the NSA, but just because they weren't patched, for instance. And if you're running an electricity grid, that may not be the network you want to use for your highly sensitive data that's supposed to flip a switch in a control in an energy station somewhere. What we need is to get a description of these autonomous systems, perhaps expressed as an authorization, a trust point, as you called it, and then the routing system, in combination with the user, somehow needs to make a decision as to what is the most secure route, rather than what's the shortest route, so to speak. Yeah. So I agree that this is, I'm not sure how to call it, but you need something like this that captures the security posture of autonomous systems. Yeah.
Yeah. Well, it's like you choose your trust chain or a secure chain of transporting your data. So you. Yep. And there may be links because there is not one transport system that you use. There are hops, and then you make a score based on
Yeah, and there might be variations, right? I mean, you as a user, you may not care, and you just tell the network, okay, just give me any chain of autonomous systems that you have. I don't care. But if you're a smart energy grid operator, then you do care, and you may want to have more control over that.
Yeah, it's like you send like a premium post. So you're paying for, like that, it will be secure, it is not open, yeah, something else.
Well, you need to be somewhat careful there, because if you're going to do, so one of the challenges of the internet originally was not to introduce any per flow state in the network, because if you do that, then the amount of state you need to keep, or the amount of memory you need in a router will explode. It's already quite challenging now with the current way of handling traffic in the internet, which is based on aggregations. So if you go more fine-grained, then that might be a risk for the scalability of the system. So that's also one of the challenges that we need to address here. How do you fold that trust marker concept or something similar into this technical system without reducing the scalability of the network?
Thank you very much. Thanks, Cristian.